Statistics, Business 226. In Chapter 2, which we're going to cover today, we're going to start using some of the activities, some of the processes that we're going to use the entire semester. We're going to look at descriptive statistics. And if you recall from Chapter 1, that's really summarizing and presenting data, giving us tools to do that. Some of those tools are establishing a mean, and if you recall, a mean is nothing more than an average. The median, which is the middle, or the mode, which is the most frequently used number in a sequence of numbers. So what is a mean? The mean of a data set is the average of all the data values. Please note in the formulas, first of all, this represents sum, the symbol sum. X bar is the mean. It's the sum of all integers divided by the quantity in the sample. And if you're dealing with a sample, you're dealing with small n in the formula. If you're dealing with total population, we switched the name of the mean to mu, and in the formula we're dealing with big N rather than small n. We're going to look at how we do this. First of all, a mean, and we're going to use an example from the Apex call center. It's the number of calls that are being received by our cumulative. And if we look at the mean, we're looking at there's 72, first of all, data points that are being measured. We add up all of the integers, divide by big N, which is the total population, and the mean for this entire block of numbers turns out to be 509. Next, we're going to look at median. And what does that mean? That's the middle value in an ordered list of data. If we look at this, we've got 72 data points. So 72 data points divided by 2 is 36. So the average is between 36 and 37, always looking upward. And if we look, the 36th and 37th number are both 517, so our median is 517. The last area that we're going to look at here is mode, and what number is occurring most frequently in the data set. And as you look through all of these numbers, they're all in sequence. The only one that comes up 3 times is 517. So 517 is your mode. Next, we're going to take a look at variation in the data set that we're looking at, and we're going to call these 4 different things. The first one we're going to look at is range. Range, the second is mean absolute deviation. The third is variance. The fourth is standard deviation. I'm sure most of these aren't new terms to you, but we're going to go back and review one additional time. The range is nothing more than the smallest and the largest data value, taking the difference between the two, and that's the range of the data set. The mean absolute deviation measures the average absolute distance of values in the set from the data set mean. We've already calculated the mean. That's either x bar or mu, as we've talked before. The MAD then becomes the sum of the individual integer minus the mean divided by either the small n or the large n. Again, and it becomes important to remember that small n represents a sample data set and big N represents total population. The variance is the average of the squared differences between the data value and the mean. Again, the formula is the sum of x bar, or I'm sorry, the integer minus x bar squared divided by n minus 1. In the case of a sample data set. In the case of a total population, it's the same formula, but you divide by n, total population, big N. Now, it's important to remember that with the sample size, sample set, you're always going to subtract 1 from the sample size. When you're dealing with total population, you don't subtract 1. You're dealing with the total population, so you get an exact number. What is the standard deviation? It's the positive square root of the variance. So we've taken, same conditions as before, we've taken the sum of the integer minus the mean squared divided by n minus 1 and take the square root of that. And if you're dealing with total population again, let me emphasize, divide by the total population number, and that gives you sigma. Interpreting standard deviation, what is that? It's the approximate, the average distance between the individual values in the data set and the data center. If we look at Apex Call Center, the range, 989 minus the 13, the range is 976. Mean absolute deviation, as we went through that before, 247. The population variance, mu squared, 88,648. The standard deviation is the square root of that, or 297.7 calls. In this chapter, we're also going to start working with frequency distribution. It's just a tabular summary of a set of data showing the frequency of items in each of the overlapping classes. We're going to use the Bank of Ozarks example that is available to us. There's 20 different times during the day that they're measuring the number of customers that are waiting at the teller, waiting to talk to a teller. Frequency distribution shows number of customers and the frequency that it occurs during that time period. You'll notice zero customers waiting happened 3 times. 1 customer waiting 6, etc., until they had 20 periods of frequency. So how do we establish the mean for that? We're dealing with the total population again, so we're going to be using mu. We look at x as the number of people, the frequency of x occurring. There was a total of 20. And if we look at how do we establish mu, we take x times the f of x, add those numbers together, add the f of x together, we end up with 44 divided by 20. Mu is 2.2. Median, same type of process as we used before. How do we establish variance and standard deviation? We've established what x is. We've established what f of x is. X minus mean the mu, or I'm sorry, the individual minus the mean, which is 2.2. We've established that. Now we're going to square that. 2.2 squared is 2 negatives make a plus, 4.84. Add those up. So now we've got the f of x, going through again the math to come up with the standard deviation and the variance. We go through the math to say, okay, 4 times 4.84 times 3 is 1452. Add all these numbers together, you get 4520. 4520 divided by the f of x, which is 20, gives us 2.26. And as you recall, standard deviation, we take the variance, find the square root of that, and the square root of 2.26 is 1.5. Frequency and relative distributions. An example, when there was no customers waiting, 0 customers waiting, it happened 3 times. 3, total quantity was 20. 3 divided by 20 is 15%. Important to note here that when you get all done with the relative frequency distribution with each of the customers, that has to add up to 1.0, total population again. The mean, how do we do that? Same as before. P times the f of x. Go through the formula. 2.2 is the mean, or in this case we call it the mu. How is the median calculated? Where do we determine what the median is of these numbers? We have to get to 50%. So if we add down on the p of x, we got 15%, 30%, gives you 45%. The mean is right at 2.0, at the end of 2.0. I'm sorry, that becomes your median. Calculations for variance and standard deviation, same as previously. Variance, calculate 2.26. Standard deviation of the variance in this case, same as we calculated before, 2.26. Standard deviation is the square root of that, 1.5. Cumulative frequency distribution shows the number of items with values less than or equal to the upper limit of each class. In some cases, if we think back to the phone calls, we had a lot of numbers in there. You may not at times want to take all numbers and have 72 points of distribution. Maybe you want to take everything from 0 to 100, 101 to 200. And how the method of doing that then is to take 0 to 100, take the midpoint, which is 50, into your calculations, and that becomes your means of calculating your distribution. Same process here, Bank of Ozarks, cumulative distributions. 3, 9, 10, 14, and 20, additive. 1 between 0, at 0 it was 3, less 0 to 1 it was 6, that cumulative becomes 9. Number waiting in line. Frequency, quantity of customers in a line. So the mean, again, of the call center, total population, large N, divide by 72. Here's your call center distribution with the frequency. Another common graphical representation is a histogram. This becomes the histogram. To compute the weighted average, treat the midpoint of each interval as the representative value for all of the group or the class. That concludes what we're going to look at in Chapter 1. Again, tools that we'll use the entire semester.